And in this video I'm going to talk about the intercept. I'm going to specifically talk about how to calculate it, interpret it, but I won't talk about how to do the significance testing in this video. So if you remember, the equation for the line of best fit is this. This is our equation for the line of best fit. And I want to use this equation to find the intercept. So what we can do is subtract off bx from each side, so the slope in x, so minus bx minus bx. And on the right side they cancel out, and so then we have y minus bx equals a. And if you want to rewrite that to have a on the left side, because that's what we're looking for, you can say a equals y minus bx. So this will be helpful in finding the intercept, but we need to fill in the y and the x. We know what the slope is already, but we need to determine what to put in here for y and x. So you should remember, I told you this before, that the averages will be on the line. So here are the averages for this example. So for the predictor variable, the average is 4.67. So if we put a line there, it goes there. And the average of the outcome is 6.3. If we put a line there, it goes right here. And if we put a dot where those intersect, it's about right here. And you can see that dot is on that line. So if we use these two averages in our equation of a equals y minus bx, so we just put bars over top of them and use as averages, and we already know what the slope of b is, then we can find a, the intercept. So here is the final equation that we're going to use to find the intercept, and it's a equals the average of the outcome. That's the average of the outcome minus the slope times the average of the predictor. Okay. So we're going to do an example again, and we're going to use the test scores data. And here it is. Here's the scatter plot of the data and the line of best fit, and I'm going to extend this line over to the intercept. And the intercept would be wherever this line hits the y-intercept, where x equals 0. So it's somewhere a little above 80, and in a minute I'm going to try to figure out what that is. Somewhere there where those two lines intersect. And you can kind of see that, or you can't see that I'm extrapolating. And what I mean by that is I extended the line past where we have data. So I only have data over here where we kind of have scores over 50, or at least 50. And I extrapolated all the way to 0. So it's kind of unlikely that someone would have an exam score of 0. Or not a lot of people would. Maybe one person just didn't take the test, and we might have a data point over there. But it's not a frequent score. Hopefully it's not, right? So it's kind of fishy to extrapolate all the way over here. And so you don't want to extrapolate over there normally, but when we're doing a prediction line, when we're doing a line of best fit, we kind of have to figure out what the intercept is so we can make predicted values. But when we're doing significance testing of the slope and of the intercept, you probably just want to interpret the slope. You can interpret both, but just interpret the intercept with a grain of salt, because this isn't exam score of 0 isn't really very a good choice to look at that point on the line. So in a little bit, after I show you how to get the t for the intercept, I'm going to talk about what is called centering. So centering is a good option when x equals 0 is kind of meaningless. It's not a good choice to look at that point on the line. But if it was a good choice, if 0 kind of makes sense for that example, for that problem, then you don't have to center. But sometimes centering helps when this intercept's not very meaningful. Or you can just do the intercept, calculate the intercept just for prediction purposes and not really care about the significance test of the intercept. So most of the time we're more interested in seeing if the slope is significant versus the intercept anyway. So you could just leave it like this. But in a little bit I'll show you how to center it. But first I want to show you how to get the intercept by hand, and remember we're going to use this formula here. And this is what is known for example. The slope is 0.04, average of a predictor variable x is 78.6, the average of our outcome variable is 86.2. And so I'm just going to fill this in. So a equals 86.2 minus 0.04 times 78.6. So let me put this in my calculator, and we're going to do order of operations. So I'm going to do the multiplication first. So I'm going to do 0.04 times 78.6, and I get 3.144. And then we need to do the rest of it. So we're going to do 86.2 minus 3.44. So let me put that in my calculator. And I get 83.056. So that's our intercept, our y-intercept. So it's not too bad as long as we have the information that we need. You want to be able to interpret the slope after you calculate it. And here's a generic sentence about this intercept. So you can say when x equals 0, I predict y to be a units, where a is the intercept that you calculated, so it's that number. And then you want to talk about the units in some kind of way. So whatever you're measuring your outcome in. So in this case it's in test points. That's our unit for this example. So we can say that when someone scores 0 points on exam 1, that I expect their exam 2 score to be around 83 points. So that's just for this example. So again, when someone scores 0 points on exam 1, then I expect their exam 2 score to be around 83 points. But again, maybe knowing what someone's exam 2 score would be if they had a 0 on exam 1 might not be very helpful to you. And so you might want to consider centering, which is the next video. But you don't have to center. If 0 is meaningful, then you probably don't want to center. But in this case, it's not. So we probably want to center, which will be explained in the next video.